Have you at any point contemplated whether we're truly alone in the universe? Or on the other hand, if there's another component to our reality than what we see? Envision if the James Webb Telescope at last showed that we live inside a black hole. Join us as we investigate this indispensable news that could make you question all that you assumed you had some awareness of the universe. So, what precisely are black holes? They're like something out of a bad dream. Sure, you could have seen them in science fiction films, but they're substantially more startling than that. As depicted by researchers, black holes are objects in space that contain huge measures of mass, stuffed into a tiny region. Picture a star a few times bigger than the sun, all crammed into a space the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape from it. Researchers have been interested in black holes for quite some time. They've studied objects in space, the fact that they are so large and thick that they can trap light. The most renowned speculations about black holes were anticipated by Einstein's theory of general relativity. Basically, when a huge star comes to the end of its life, it collapses, leaving behind a thick center. If this center's mass is several times that of the sun, gravity overpowers everything, leading to the formation of a black hole. It's difficult to detect black holes since they emit no light. However, researchers have found ways to deduce their presence by observing their impacts on surrounding matter. For example, if a black hole passes through a haze of interstellar matter, it will pull that matter towards it in a process known as accretion. Moreover, when a regular star gets too close to a black hole, it may be destroyed, releasing X-rays in the process. Black holes also have a tremendous impact on their surroundings. They can consume nearby stars, produce strong gas jets, and even influence the formation of new stars in some areas, while slowing it down in others. But where do black holes come from? Picture stars that were once superb, detonating in an event called a supernova. From the remnants of these fallen giants, black holes are born. Most black holes arise from massive stars that have reached the end of their lives in a supernova explosion. Smaller stars, when they die, turn into neutron stars, extremely dense objects, but not dense enough to trap light. When a star is several times the mass of our sun, it falls under its own gravitational pull, forming a black hole. As powerful as these collapses are, a strange thing happens near their surfaces. Time itself starts to play tricks. From the perspective of someone far away, time appears to slow down near the event horizon, the final turning point for anything falling into a black hole. It's as though the star's clock ticks at a different speed compared to ours. Sometimes, when two smaller black holes collide, they merge to form a much larger and more alarming black hole. If a black hole interacts with a neutron star, they create a situation that defies understanding. Researchers have been wrestling with the size of these gigantic anomalies for a long time. Black holes come in two sizes. Of all shapes and sizes, there's a mysterious secret surrounding them that we can't completely unravel. Anyway, here's the twist: little is relative when it comes to black holes. Extremely large black holes, the remnants of massive stars, can be as massive as 10 to 100 times the size of the sun. There could be anywhere from 10 million to a billion of them in the Milky Way alone, a staggering number of black holes that could swallow anything in their way. But hold on, there's something even bigger. Very large black holes exist at the other end of the spectrum. These black holes are millions, if not billions, of times more massive than the sun. They exist at the centers of massive galaxies, including our own Milky Way. It's like a giant black void pulling everything toward it. The famous physicist Stephen Hawking spent much of his life studying black holes. His theories were profound, though some of them couldn't be confirmed due to a lack of necessary equipment. Still, hope is on the horizon. A single scientific instrument is making a huge difference, and we're not ready for it yet. It's known as the James Webb Space Telescope, JWST, and it's set to explore the depths of our universe. Let me tell you, the JWST is no ordinary telescope extension. It's an engineering wonder, an exhibit of human aspiration. Sure, we've launched other space telescopes before, and they've done their job well, but this one is truly remarkable. The JWST makes the Hubble Space Telescope, which has served us for years, seem like a fundamental speck in the universe. The price tag for this astronomical marvel is a staggering $10 billion. Yes, you heard that right. Zeros to blow your mind. NASA, the European Space Agency, and the Canadian Space Agency have cooperated to bring this wonder to life, alongside contributions from over 300 universities. But we mustn't overlook the dangers that come with such a monumental undertaking. The JWST is venturing into unknown territory, pushing the limits of what we know and taking us to places we've only dreamed of. After a successful launch, NASA recently announced that the telescope has enough fuel to last over twice its base mission life. Since its launch, the JWST has already achieved countless incredible accomplishments, traveling over 1 million miles to reach its orbit around the Sun, where it will remain indefinitely. During its journey, the telescope successfully deployed its massive 5-layer sun shield and large primary mirror, both of which had to be folded to fit onto the launch vehicle. Now that NASA has adjusted and calibrated it, the telescope is almost ready for full operation. One of the most exciting parts of the James Webb Space Telescope was when NASA revealed that it had captured its first images of starlight. The first image taken by the telescope was of a star called HD 8446, resulting in a mosaic of 18 scattered bright spots from the star's light, captured by the 18 mirror segments on the primary mirror. NASA later released another truly remarkable image of HD 8446, where the 18 unfocused copies of the star were combined into a hexagonal arrangement. Once the observatory successfully aligns the individual segments of the primary mirror, it will begin the image stacking process, combining the 18 images into one clear picture. Once the James Webb Space Telescope, JWST, achieves full alignment and begins combining the 18 images into one clear picture, it will open up new possibilities for astronomers and scientists. The JWST's incredible capability to capture distant light and peer into the deepest corners of the universe will help unravel mysteries that have puzzled us for centuries. Its advanced technology allows it to see further than any telescope before it, observing objects that are billions of light years away. The telescope's infrared capabilities are especially groundbreaking. It can detect faint light from objects that are too distant or too dim to be seen by optical telescopes like Hubble. This includes the light emitted by the first stars and galaxies formed after the Big Bang. By observing these distant objects, scientists can learn about the origins of the universe, how galaxies formed, and how black holes evolved over time. Furthermore, the JWST will be able to observe exoplanets in great detail, analyzing their atmospheres for signs of life or the ingredients that could support life. This is a major step in the search for extraterrestrial life, as the telescope's precision can reveal chemical signatures that might indicate biological activity. As the JWST continues to send back data, it will likely challenge many of our existing theories about the universe. New discoveries are expected to revolutionize our understanding of space and time, and perhaps even push the boundaries of science fiction into reality. From studying black holes and dark matter to examining distant stars and exoplanets, the possibilities for new discoveries are endless. However, as with any major scientific venture, there are still many unknowns. The JWST is exploring uncharted territory, and while it has already achieved remarkable feats, the full extent of its capabilities will only become clear as more data is collected. Its journey into the unknown may lead to groundbreaking revelations, offering a clearer picture of the cosmos than ever before. In the years to come, as more images and data are gathered, the JWST will continue to inspire generations of scientists, astronomers, and curious minds worldwide. This magnificent telescope is not just a triumph of technology, but a testament to human ingenuity and our unrelenting desire to explore the universe, seeking answers to the most profound questions about our existence. Thanks to its forefront innovation, the JWST will help analysts concentrate on the beginning phases of the universe after the enormous detonation. It will center around what occurred after the first stars framed, a period known as the Epoch of Reionization. This period alludes to the point when impartial hydrogen was reionized, made electrically charged again by radiation from these first stars. This includes thinking back billions of years, which is only conceivable with a strong telescope like the JWST. The telescope will also assist researchers with finding exoplanets, which are staggeringly challenging to recognize due to the manner in which they interact with their host stars. Its strong sensors will be capable of noticing these planets in more detail, including imaging their atmospheres. Figuring out the conditions and states of planets could help researchers better predict whether certain planets are livable. Other than concentrating on the development of universes, analysts are also focusing on galaxies to understand how matter is coordinated on an enormous scale. This, in turn, allows us to see how the universe has evolved. The twisting and circular galaxies we see today developed from various shapes over billions of years. One of the JWST's objectives is to glance back at the earliest systems to better understand their development. Researchers are also attempting to figure out how we wound up with the scope of galaxies visible today and the current processes by which galaxies form and gather. However, most significantly, the James Webb Space Telescope will help us answer the most key questions of all. Are we alone in the universe? Are we living inside a black hole? The JWST has already been on the chase. And guess what it found? Compounds called polycyclic aromatic hydrocarbons, PAHs, around those huge, very large black holes in 3 active galaxies. These carbon-based molecules with ring-like structures are everywhere from far-off galaxies to comets in our nearby solar system. Now, they're not simply intriguing because they could be the building blocks of life, but also because they help space experts track star development. When ultraviolet radiation hits these PAHs, they shine and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument, MIRI. This often indicates the presence of hot, young stars. But wait for the twist. Astrophysicist Ismail Garbernard from Oxford University decided to concentrate on 3 active galaxies: NGC 6552, NGC 70319, and the famous Stephan's Quintet, millions of light-years away. What Garbernard found will make your hair stand on end. In the central areas of these galaxies, where black holes dominate, he found a mass of PAHs. Sounds fantastic, right? Here's where it gets chilling. The radiation close to those very large black holes twisted the PAHs, evolving them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs evaporated into nothingness, like being consumed by the darkness itself. But wait, there's a promise of something better, or perhaps not. The extreme question here isn't whether we're alive, but whether we truly exist. Does everything around us exist because of the black hole we're in? All things connect with the theory that perhaps we're not just living inside a black hole, but instead inside the event horizon, the line between the universe we know and the unknown. Might it be that everything is interconnected inside a black hole? The James Webb Space Telescope is out there right now, looking for the answers to the unknown. Stay tuned, and maybe, just maybe, it will make all of us rethink what we assumed we knew about existence. Reality may be far more wound than we understand. As the JWST continues its mission, it will push the limits of our understanding and perhaps answer questions we've been asking for hundreds of years. It's not just a telescope. It's a window into the profound secrets of the universe. Its discoveries could not just uncover the mysteries of black holes and exoplanets, but also help us understand our place in the universe. Will it answer whether we are truly alone? Will it help us find other life forms, maybe hidden in the depths of space or in the atmospheres of distant planets? The JWST's strong instruments are capable of probing much deeper into the universe than any telescope before it, uncovering patterns and phenomena that were previously invisible. It's an instrument that could change everything we thought we knew about the universe, gravity, and, indeed, even time itself. The more we understand black holes, the more we might realize how interconnected everything in the universe really is. Maybe we are all part of a bigger, enormous story, one that the JWST will begin to unravel. But the answers it reveals won't come without more questions. The more we learn, the more we might wonder about the true nature of reality. Are we just passing through an inevitable investigation? Or are we, as we appear, part of a greater plan? one that spans across dimensions we can't yet comprehend? The JWST will be at the very forefront of this inquiry, looking at the universe in ways that challenge our imagination and figuring out what's more. The telescope will likely change the fate of space exploration and the way we think about different galaxies, stars, and black holes. As we move further into the unknown, the JWST vows to assist in unlocking the most profound corners of space, perhaps allowing us to understand things like the Big Bang, dark energy, or the true mechanics behind gravity. It's an exciting thought that, with the aid of this astonishing machine, humankind may reveal answers that have eluded us for centuries. As we simply relax and take it all in as its revelations unfold, one thing is sure. The James Webb Space Telescope represents humankind's hunger for knowledge, our unflinching curiosity about the universe, and our drive to comprehend the unexplored world. It's more than just an investment or an instrument. It's a reflection of who we are as a species, looking to the stars not only for answers but also for understanding. As we look to the future, the James Webb Space Telescope, JWST, promises to unlock even more secrets of the universe. Its advanced technology and unparalleled capabilities will continue to push the boundaries of our knowledge, allowing us to probe deeper into the cosmos than ever before. From examining distant exoplanets to understanding the origins of the universe itself, the JWST is poised to be a game-changer in the field of astrophysics. What makes the JWST so special is its ability to peer into the infrared spectrum, enabling scientists to see through cosmic dust and observe distant objects that are otherwise hidden from view. This ability allows us to study the formation of stars and galaxies in ways we never thought possible, giving us insights into the earliest moments of the universe after the Big Bang. The telescope's impact won't just be limited to academic research. The discoveries it makes could have far-reaching implications for humanity's future. By studying exoplanets and their potential for habitability, we may uncover new worlds where life could exist. This could provide crucial information in the search for extraterrestrial life, answering one of humanity's oldest questions: are we alone in the universe? In addition to this, the JWST's ability to investigate black holes and dark matter could help us answer fundamental questions about the nature of gravity, time, and space itself. Its observations could reveal the mechanisms that drive the formation of galaxies and the mysteries of cosmic evolution, helping us understand how the universe has come to be the way it is today. But the most profound aspect of the JWST may not be the specific discoveries it makes, but rather the new questions it will inspire. Each answer will likely lead to more mysteries, pushing us to reconsider our place in the cosmos and challenge our understanding of reality. We may come to realize that we are part of a much larger, more complex story than we ever imagined. In the end, the James Webb Space Telescope represents the culmination of human ingenuity and the thirst for knowledge. It is more than just a technological achievement. It is a symbol of our desire to understand the universe, to explore the unknown, and to seek answers to the most profound questions of existence. As it continues to unveil the mysteries of the cosmos, the JWST will undoubtedly reshape our understanding of the universe and our place within it, inspiring generations of scientists, dreamers, and explorers for years to come.